Okay, hopefully it works this time. I've already recorded this a couple of times, and we'll give it another go. All right, I wanted to go over some of the probability problems from today because I got some questions. I figured it'd be a good idea to go over some of these differences and stuff because you have some different approaches for these problems. Now, this one's based on the AP Physics exam. You have 20 multiple choice questions, and each question has 5 possible answers. We're assuming we're blindly guessing, so we want to find the probability that. Now, first thing I established was that you have a 1 in 5 chance of getting it correct and a 4 in 5 chance of getting it wrong. Why? 5 choices, 1 of them is correct, 4 of them are wrong. I also put up the probability formula here for binomial distributions. So you'll notice that I highlighted the first part here. That represents the number of combinations. That's the first thing you're usually figuring out. And then what you're given here is the probability of these events happening, essentially. Now you have to find the combinations because you want to imagine that in most cases you're thinking of a really intense tree diagram. And essentially you're finding the same probability, but it's coming up a bunch of different times. You don't want to have to draw it out and, figure out, from a visual how many times it's coming up. So that's why we have this combination function. And one thing I always put here, this is a good rule of thumb. For most part, order doesn't matter with binomial distributions. So that's why we use that combination formula, because we figure order doesn't matter. There can be a lot of different things going on here. Now, if order does matter, you're not going to be using some sort of binomial calculation. You're not looking at binomial distribution. So let's take a look here. So notice I already did some of these answers. I'm going to erase them just so you can see where they came from. The first one asks that the first 10 questions are correct. Now, first thing people usually ask, where does the wrong probability come in? It doesn't. All you care about is those first 10 questions being correct. It really doesn't matter what happens on that 11th question. 11th question could be right, could be wrong. Doesn't matter because we're making no assumptions here. All we care about is that first 10 questions. So one way you could do this, and I don't recommend this, is going with a tree diagram. 1 in 5 chance to get it correct, 4 in 5 chance to get it wrong. And then we really care about getting it correct, so we're going to stick with this. Off of this branch, what could happen on the second question? 1 in 5 chance you get it right, 4 in 5 chance you get it wrong. Okay. And again, I'm only caring about getting it correct. What could happen then? Okay, third question. 1 in 5 chance you get it right, 4 in 5 chance you get it wrong. I can keep going, building off of these correct branches until I get all the way up to 20, or all the way up to 10, in this case. A lot of work, I don't recommend it, because essentially all you're going to end up doing is multiplying all these probabilities anyway, which is going to end up being 1/5 to the 10th power. Again, we don't care about getting them wrong, and in this case, order matters. Next one says the first 10 questions incorrect. Okay, it's the same principle, only this time we're concerned about this wrong branch. So, okay, 4 out of 5 wrong. Okay, what could happen? Second question, 1 in 5 chance you get it right, 4 in 5 chance you get it wrong. Okay, what could happen on the third question? Same thing. Notice we're only building off the wrong branch. That's the only one we care about. 4 out of 5 wrong, 1 out of 5 right. It's the same principle. We can keep going all the way up to 10, but it's going to be a lot of drawing when all we're going to end up doing is just multiplying here. We're going to end up multiplying 4/5 10 times. And that's how you calculate it. You can write, notice I just wrote it out. You guys can do the calculating. You got calculators. I just want to show you how to get there today. I'm just going to erase this. Okay, now the next one. You answer the first 5 incorrectly, and the next 5 correctly. Again, you'll notice I don't have a combination function here because there's only one possibility of this happening. First five are wrong, next 5 are right. That's it. I don't need to use my combination function here because, again, it's like a long branch on a tree diagram. Again, wrong. 4/5 wrong. 4/5 wrong. Keep going 5 times. And then after that, we're going to go 1/5 right. And then keep going. Again, you're only thinking about one branch on that tree diagram. Now when we get to number 4 here, this is where we're thinking about combinations because it says half of them correct. You have 20 questions here. In theory, you could answer the first 10 correct, the next 10 wrong. Maybe you get the first one correct, 9 wrong, next one correct, next 9 wrong. You don't want to write out all these combinations. Trust me, because it's going to take you a long time. What you use is you can use that calculator function, that NCR, and I'll show you how to get there on your calculator. What you do is you go to Math, Probability, NCR. And okay, we're looking at 20 trials, 10 successes. And this will tell us how many combinations there are of 10 successes within 20 trials. 184,756. I don't know about you. I don't want to have to write out all those combinations. And you shouldn't have to. That's what the calculator function's for. And that's where this number comes from. This means I would have 184,756 branches on a tree diagram that all have 10 correct answers and 10 incorrect answers. And again, order doesn't matter here. It could happen in any order. Same thing here. Answer 15 right. Again, same thing. You have a bunch of different combinations. Essentially, you can do the NCR function. You would find that you have 15,504 branches on a tree diagram that would have 15 correct answers and 5 incorrect answers. So that's what that function does. Now you can also use Binompdf. Some people like doing that. I'm not a huge fan of it, but I'll show you how you can go with it. I like the formula because technically when you see it on the AP exam, chances are if it's a multiple choice question, you'll see it in the formula, just like so. So you notice I set this up using the formula. 19 wrong, okay. In this case, I would consider wrong being a success and correct being a failure. Now if I use Binompdf, now the difference between Binompdf and Cdf, the C stands for cumulative. It starts at 0 and adds up every probability up until you tell it to stop, starting from 0. Binompdf, I like to think of it as perfect, precise. It's only finding the one probability you're asking it, which in this case was that 19. So how do you find that? Second, vars, go down to its distributions, Binompdf right here. Now I would enter total number of trials, probability of success, which in this case is 8.8, and then that perfect probability that I'm looking for. Excellent. I don't recommend doing this, but you can, because a lot of people tend to confuse it with Binompdf. If you do it, make sure you're labeling. You want to make sure you're getting credit, make sure you label. I also did the same thing here. I ended up going with the combination formula. I like doing that. I think it's the best way to demonstrate it. Now, here's where people start to get a little mixed up. When you get these at least questions, like in this case, it says you get at least one right. So here's the strategy I had. I started at 0, went up to 1, and then after that I could go 2, 3, 4, and so on, all the way up to 20. Which ones am I concerned with? It says at least one right. So that could be 1, 2, 3, 4, all the way up to 20. So I need to find the probability of those. And I don't need that one. Now, Binompdf will not work here because it starts at 0. That's not going to help because it would start at 0 and go all the way up to where I tell it. I can't use Binompdf here. However, I guess I could, find the probability of 1, add the probability of 2, 3, go all the way up to 20, but that seems a bit much. If I just find the probability of 0 and subtract it from 1, that'll give me everything left. So if I find the probability of 0, take away from 1, and I get everything else I need right here. And you'll notice when I wrote it out, I didn't even use Binompdf or Cdf. Why? Because there's only one order possible if you get all 20 wrong. There'll just be 20 wrong right in a row. So I did 0.8 to the 20th. Again, I subtracted it from 1, and that gave me everything else I was looking for right here. Now in this case, it says answer 3 or less correct. So what I did was I went 0, 1, 2, 3 up to whatever I needed. And then I could go ... all the way up to 20. And I think, what do I need? I need 3 or less. So that could be 3, 2, 1, or 0. And I don't need these. So I did go with Binompdf. Why? Because Binompdf says, okay, we'll start at 0, and we'll go all the way up to the number you give us, which in this case was 3. That's the way I did it. Here's one where people make a lot of mistakes, these type of questions. It says answer less than 7 correct. So you notice what I did was I did 1, 2, 3, 4, 5, 6, 7, 8, ... all the way up to 20. It says less than 7. So which ones do I need? 6 is less than 7. All the way down to 0. These are the ones I need. I don't need 7 all the way up to 20 because it says less than 7. So I end up going with Binompdf here because what that does is it says we'll start at 0 and we'll go all the way up till whatever number you give us, which is 6. We'll add those probabilities for you and we'll give you that answer. So hopefully this helps you out with some of these probability problems. They can be a bit tricky, especially, depending on the context you see them. So just beware, think about what they're asking, does order matter, and then think about, what kind of calculator functions you can use. Again, if you ever have any questions, feel free to reach out.